Hello, you absolute legends. My name is Don Cavanaugh, and this is about changing equilibrium, or Le Chatelier's principle. And I want to focus really on the changing of the temperature right here, because that seems to be the one that trips people up the most here. When a reaction is at equilibrium and we attempt to stress it, there are four things the chemists do, and in levels of increasing difficulty, this is what we do. The first thing we do is we change the temperature. It's probably the easiest, the simplest, the cheapest. The second thing we do is we add something. We add a reactant or we add a product. Third thing we do is remove something. It's always harder to, when it's liquid phase stuff, it's usually harder to remove stuff than it is to add stuff. That's why it's third. Removing a product or removing a reactant. Third one is to change the pressure or the volume of the gas, of the reaction. But the caveat is this only works with gases. Okay? So if you have one reactant or product that is a gas, then this is on the table and viable. But if everything is a solid or a liquid, no mas, no dice. How to change equilibrium? Changing the temperature. Let's talk about that one specifically. Here is a balanced chemical reaction that involves gases. We have gases as reactants and gases as the products here. To know what to do about temperature, you have to understand if it's endothermic or exothermic. The sign of the enthalpy value will tell you if it's endo or exothermic. This one is a positive value, so we conceptually think of heat as a reactant. When you have a positive value for the enthalpy term, we conceptually think of it as an endothermic reaction. And colloquial, or to your sense of touch, we would say cold to touch. Okay? With the thought that heat is a reactant, we go back to our seesaw analogy. If I increase the temperature, that is equivalent to increasing a reactant. So my reaction is out of equilibrium with this seesaw analogy. Therefore, to get back to, for this thing to tilt back to level, this has got to get heavier, this has got to get lighter, the reaction's got to go this way, more products are going to be produced. Products are going to go up, reactants are going to go down. All of the reactants are going to go down, all of the products are going to go up. If I decrease the temperature, so if I decrease the temperature, it's equivalent to removing a reactant conceptually. Removing a reactant, that's what the seesaw is going to look like when a reactant's been removed. The reaction's got to go this way, uphill, to get back to equilibrium. So it's tilted like this and it's got to come back to level. For it to go that way, that means that more reactants will be produced. Reactants are going to go up and products are going to go down. I hope this helps. Thank you.